All right, so how do you solve this problem here? What's the change in kinetic energy? Um, so we're looking at a 5 kilogram mass here that is moving across the surface that's frictionless up until this one point here where it's about 2 meters of something with friction. Oh, I forgot the kinetic. The coefficient of kinetic friction, mu sub k, is 0.2. That's the one thing that I left out. Okay, so how do you do that? What is a change in kinetic energy? So obviously this thing has kinetic energy, and you can find that as 1/2 mv squared. What I was looking at when I solved this problem is this thing will lose kinetic energy when it hits that surface because friction. And so the way that you see this, you can solve this is how much work was done by friction. So that's what I asked myself. What was the work done by friction? That is what I asked myself. How much work did friction do? And if you remember, like the general equation for work is the force times the displacement. I'm gonna use the notation you'll see in the AP Physics 1 equation sheet, and times the cosine of theta. And remember, this theta depends on the angle. In this case, friction is acting like here in the opposite direction of the travel. And this thing is zero, according to like, it's not at an angle, it's zero, and cosine of zero is one. I'm going pretty quick here, but one of those things, like if the force is in the same direction or even against this direction of the displacement, you can go ahead and say that the cosine of zero is one. So in this case, the displacement is over here, and friction is this way, so they're parallel, and so it's one. What is the force here is friction. And so I'm gonna go ahead and define this. Work is friction times d. Remember, theta is equal to zero. Let's put that here. And you can prove it to yourself. If you put that in, you get that equal to one. F times d. Now, what is the force of friction? So I want to remind you of how do you define the force of friction. You can always look in your equation sheet. It's weight, the normal force times the kinetic. It'll be mu sub n. That's how they kind of write it. And n, if you look at the free body diagram of this block, you have weight is equal to n. And so we can go ahead and take the next step to say that the normal force is equal to weight because this thing's on a nice flat surface. And so friction, weight is mg. So you have mu mg. And let's go ahead and finish this off. So what's the work done here? Work, when we put this in right here, is mu mg times your displacement. And we have all that stuff. So this is going to tell us how much energy is lost because of the work done by friction. That's what it's going to tell us, right? That's what we're looking for is how much kinetic energy did you lose? And so let's go and find that out. The kinetic coefficient of kinetic friction is 0.2. Our mass is 5. And I'm gonna go ahead and leave out the units. I hope that everybody's okay with that. I went ahead and used 10 for G, and your displacement in this case would be the work is only being done for 2 meters. So when you plug that in, let's see, that's 50 times 2 is 100, and that's 20 joules. And so this thing loses 20 joules of energy due to friction. And so if you look at the equation here, you'll see that the only answer that does that is 20 joules of energy is removed from the block, which is A. Okay? And that's how you do that.